This week in one of my classes, we're covering the network layer. So what will we be going over in terms of the network layer? Well, we're going to be going over IP, the Internet Protocol. We're going to be talking about routers and the function of routers at the network layer. We're also going to talk about routing. And particularly in routing, we're going to be talking about the routing table. Not just the router's routing table, but the host, the computer, your PC, your host computer's routing table, and default gateway. Big topic. And we're going to do some basic configuring of the router. So these are 4 things that we'll be going over this week. So what do we want to say about IP, Internet Protocol? Well, a lot. But first off, in terms of IP, we're talking about IPv4 addressing, IPv6 addressing. You're probably most familiar with IPv4, but for the Cisco CCNA and for just the way things are changing, you need to become more familiar with IPv6 addressing and how it functions. And then ICMP, the Internet Control Message Protocol. This is used when we ping a host on the network, but it's also capable of relaying all kinds of other messages, especially in relationship to IP. So this is an error reporting messaging protocol that works with IP and also with routers. And then logical addressing. IP addressing is logical addressing, as opposed to layer 2 physical addressing, which is MAC addresses. MAC addresses are burned into the network interface cards, into your network adapter, and we call those physical addresses. Those are MAC addresses on an Ethernet LAN. But IP addresses are logical addressing at layer 3. We can choose, an administrator can decide what addressing scheme they want to address the network with, and then the hosts will have those addresses. Or think of it like this: when you configure a DHCP server, you can decide what the pool of addresses you're going to hand out are going to be on the network. So it's a logical process. Functions in the OSI model at layer 3, and in the TCP/IP Internet Protocol Suite, we call it the Internet layer. All right, we're also going to be learning about routers. Now, what about routers? Well, routers function at the data plane regarding forwarding. At the control plane, when it comes to routing, they're also responsible for quality of service, QoS. For QoS is when we need to prioritize different types of traffic, namely voice over IP phone calls, streaming video, things like that. And then the newest topic related to the network layer is software-defined networking. So this is a different way of implementing routing on a network at the software level. It basically separates the forwarding plane from the control plane, and then the control plane, which is controlling basically the routing functions, can be centralized to a centralized server. When we talk about routing, we're really talking about the routing table, like I said, and we're going to talk about that some more, and then configure the router. So let's first of all look at IP. All right, so the Internet Protocol, IP has its own packet header, and that IP header is added to the transport header and data. So here you have I have a little image here of the transport header, transport layer header, and data that are now encompassed within the IP header, and now we have a packet. At the transport layer, we had a segment, and now the segment is wrapped in a packet, and the IP header is added on. Now, what about IP? IP is connectionless, meaning there doesn't need to be a prior established connection at this layer. And what I mean by that is, like at the transport layer, we had the 3-way handshake. That's a prior connection. In other words, layer 4 is handling the prior connection, the 3-way handshake. But with IP at layer 3, no prior established connection is required. It's also considered a best effort protocol. There's no reliability built in at layer 3. There's no retransmission of the packets at this layer. That's also handled by TCP at layer 4. And IP is media independent. IP addressing, end-to-end networking across the internet works whether it's going across fiber optic cables, copper lines, or wireless radio waves. It's media independent. It's existing at layer 3, not at layer 1. Okay, IPv4 addressing. What are the basics? In my class, students are very new to this. So Here comes. Well, in an IPv4 network, we have addresses like 192.168.3, and the host address will be 192.168.3. Let's say 100. But it could be 3.1 or 3.10 or 3.50 or 3.250. But this is a typical host address. On an IPv4 network, the first address in the network is called the network address, and it's not usable. So if my address is 192.168.3.100, the network address is probably 192.168.3.0, and no host will use this address. It's reserved. It's the network address. And that's the first address in the network, 0. The last address in the network, .255, is the broadcast address, and that's used for sending broadcasts. It's the last address in the network, and that's also reserved. You don't use that address. So hosts on the network, that means PCs, computers, phones, servers, you name it, printers, they can have addresses that would go anywhere from 1 all the way up to 254. So 1 all the way up to 254 could be the host address. All right, now a network is defined by the net mask, which is also called the subnet mask. So in a typical network like this, the subnet mask is usually 255.255.255.0. And that defines the network. Well, how does it define the network? It defines the network because these 255s indicate where the network is. So 255, 255, 255, that means network portion, network portion, network portion, which means 192.168.3 is the network portion. And then the last octet is where the host goes. So effectively, this is the 192.168.3 network, and this is host 1, or host whatever it is, 13. Okay, so also on an IPv4 network, if you're going to be able to communicate outside of the network, you need a default gateway. The default gateway is the router on the network. It's the router on the network. It's how you get to other networks. So typically, oftentimes, the default gateway sometimes will be the first address on the network. So in this case, I'm 192.168.3.13, and my default gateway, the way out of the network, is 192.168.3.1. Another typical address on an IPv4 network is a multicast address. A multicast address will start with the number 224, and it's used for sending or broadcasting to groups of hosts on a network. And it usually starts with a 224 address. So that's a little bit about IP addressing. Now, what about routers? We're also dealing with routers at the network layer. Routers make forwarding decisions at layer 3 using layer 3 header information, namely the destination IP address. So the routers route and forward the data based on the destination IP address. That makes sense. Routers determine the best path through a network. Routers are different than PCs typically because they have multiple interfaces and they can take different routes. They can go different directions. So they need to determine what's the best path to take. To do that, they use their routing table. Lastly, routers make forwarding decisions, they determine the best path, and then they forward the data and moving packets from input interfaces to output interfaces. So in other words, the data is coming in, the packets are coming in on one interface, and they need to get forwarded oftentimes out of another interface. All right, now what about our host computers, my PC, my laptop, my computer? What about those? Well, our computers can also be routers. In other words, they also make forwarding decisions at layer 3. My computer makes forwarding decisions. My computer also has a routing table. You can see the routing table by putting in the command line netstat-r. Netstat space -r, and you'll see your routing table. Your host computer will also have a default gateway. And as I've said before, the default gateway is the router. It's the way out of the network. The default gateway is used to reach unknown networks, to reach basically all the networks that are not your own network. And it does that by looking in the routing table and seeing the quad 0 route that uses the gateway. And we'll take a look at that in a minute. This is for unknown networks. Networks with 0.0.0.0 and subnet mask 0.0.0.0 will go through the gateway. And this will work for any unknown network. It's also called a default route. It's your default gateway. Okay. Logical addressing. Logical addressing. So I have the address here, 192.168.44.211. That's my IP address. You take the subnet mask, and you can see the network portions here. 255.255.255 define the network, and then this 0 is where the host bits are. So this is host 211, and it's the 192.168.44 network. So the network is 192.168.44.0. The broadcast address is 192.168.44.255, and the host could be any number between 1 and 254. Now, oftentimes, you'll see the subnet mask written with /24. The /24 means there's 24 ones in the subnet mask. In other words, if I take this subnet mask right here, 255.255.255.0, and write it in binary, it gets written like this. 8 ones, 8 ones, 8 ones, and then 8 zeros. This means 255.255.255.0 converted into decimal. But in binary, it's 24 ones in a row. So that's what the /24 indicates. It indicates that the subnet mask is this. So, are the following addresses all in the same network? Yes or no? Well, we've got 192.168.44.111 /24. That's important because it defines the network. That means the subnet mask is this. If this is the subnet mask, well, then it's the 192.168.44 network, 192.168.44, 192.168.44, 192.168.44, host 1, 252, 3, and 111. Yeah, these are all good host addresses, and they're all on the 192.168.44 network. But compare that to down here. Are the following addresses all in the same network? Yes or no? We've got 172.16.2, 172.16.2, 172.16.2, and 172.16.20. Uh-oh. This address is on a different network from these three here. So are the following addresses all in the same network? Yes or no? The answer would be no. Notice they all have /24 subnet masks.